Exercise 1. Match each term with its definition by writing the letter of the correct definition in the right column on the line beside the term in the left column. So first we read all the terms and all the definitions given, then we start matching. Electric force, electric field, charging by friction, static electricity. Definitions: method in which two different materials are rubbed against each other, causing transfer of electrons. Build-up of stationary charges on the surface of an object, the region surrounding a charged object, and a push or a pull exerted by a charged body on another charged body. So the electric force is D. It's the push or pull exerted by charged body on another charged body. It is when two like positively charged objects repel each other, or two negatively charged objects repel each other, or one positively charged and one negatively charged objects attract each other. This is the electric force, a push or a pull. So repelling is pushing, attraction is pulling. Electric field, it is the region surrounding a charged object. Charging by friction, it's a method in which two different materials are rubbed against each other, causing transfer of electrons. 4. Static electricity. It is building up of stationary charges on the surface of an object. When an object acquires or loses electrons on the surface of it, on its surface. Exercise 2. Answer by true or false and correct the false statements. A neutral atom has more protons than electrons. No, this is false. A neutral atom has equal number of protons and electrons. 2. Upon rubbing two different materials against each other, the material with more tendency to lose electrons becomes negatively charged. No, the one that loses has more tendency to lose electrons will lose electrons and thus have deficiency in electrons and becomes positively charged. Charge is neither created nor destroyed; it's transferred from one object to another. This is the statement of the law of conservation of charge. This is true. Conduction allows the flow of electrons between insulators by direct contact. No, it's by conductors by direct contact. So this is false. Write the letter of the correct answer on the line at the left given the arrangement of different materials in the order of increasing tendency to lose electrons. So we have fur, nylon, silk, cotton, polyethylene, nickel, carbon, ebonite, rubber, and platinum. So going from the hair to the gold, this is increasing tendency to lose electrons. Now part 1, upon rubbing two identical balloons against each other. Identical, this means that they are made up of the same material regardless of the material itself. So if you go back to the definition of charging by friction, it is the method of rubbing two different material. So for charging to take place, the two materials rubbed against each other must be different so that one is stronger than the other, causing the other to lose its electrons and gain them. Okay? So this is not the case because the balloons are identical. So the balloons will remain in neutral. Neither would they lose or nor gain electrons. And here part B, so the option in A was and one becomes positively charged, one becomes negatively charged. No, this is not right because no one is gonna lose, no one is gonna gain, and similarly for part B. Now part 2, consider rubbing a piece of fur against a rubber balloon. We have to check the axes here. So we have the two materials involved are the rubber and the fur. Rubber has more tendency to lose electrons than fur, so it's going to lose electrons and becomes positively charged, while the other one is going to gain electrons and becomes negatively charged. So the three options given here, what's wrong about the B and C? B and C, we have that if the balloon gains 1,000 electrons, the fur loses an equal number of electrons. However, we said that due to the order of tendency to lose electrons, the rubber is going to lose, and the rubber, yes, is going to lose, not gain. The rubber balloon lose, not gain electrons. Okay, so the wrong part about part B is, or the wrong thing about part B is that balloons are said to be gaining electrons, and this is not true. They lose. In C, the balloons gain 1,000 protons. Protons are not gained nor lost electrostatically. So this is not correct to mention the protons. Protons are not particles involved in the charging process. So we are left with A. If the balloon A loses 1,000 electrons, the fur gains an equal number of electrons. This is true. So balloons, because the rubber has more tendency to lose electrons, the balloons are going to lose the electrons, and the same number should be gained by the fur. Finally, exercise 4. Sammy, a student in the physics class, performed an experiment in front of his friends. First, he rubbed a glass rod by the piece of silky cloth. Then he approached the glass rod to the top of an electroscope. He approached, he did not put it in contact. Okay? The students noticed that the leaves of the electroscope deflected away from each other as shown in the figure below. So define an electroscope. An electroscope is an apparatus used to detect whether an object is charged or not. If the object approached to the knob is charged, then the leaves deflect away. If not, if it's neutral, then the leaves remain dangling, taking their equilibrium position. So 2 here, give the experimental evidence showing that the rod was charged upon rubbing it against the silk. The experimental observation or evidence is that the leaves of the electroscope deflected away from each other. Now, knowing that the glass has more tendency to lose electrons than silk, indicate the sign of charge of the glass rod after rubbing. So knowing that the glass has more tendency to lose electrons, it's going to lose the electrons and thus becomes positively charged. Because now upon losing electrons, it will have deficiency in electrons. The protons will be greater than the electrons. Okay, and it becomes positively charged. Finally, describe step by step the physical phenomenon that takes place causing the deflection of the leaves. What happens when the positively charged rod is approached to the knob of the electroscope? Some electrons of the leaves will be attracted upwards and accumulate at the knob. Okay, both leaves become positively charged because they lost electrons, some electrons, and they repel each other.